This is New York.
triangle on it. Sure.
Yeah.
All right. Brian's gonna tell us what happened.
Okay, so the alcohol evaporated, right?
Alcohol evaporated.
And then the vapor pressure went up when that happened.
Vapor pressure went up.
And then because there was just like a bunch of alcohol, like
Vapor
just floating around.
Okay, hold on one second. So he's right. I put the alcohol in, I rolled it around, dumped it out. Put the cork on top. So now you have alcohol vapor inside the bottle. Okay.
So then the electricity ignited the vapor, and then it like pushed it all up the cap. Like it had to go somewhere, so it all went up the cap.
Okay, so the electricity, so you had the two screws, and I touched the electricity to one of them. What happened between the screws?
The bolt went through it.
The electricity jumped, it arced. You couldn't really see that, but that's what happens. If you bring two metal objects near each other and electricity is running through one of them, it'll jump across to the other one. It's called arc. So electricity will arc, and then the electricity ignites the alcohol, because alcohol is flammable. The vapor is. So then you said the vapor wants to go somewhere.
Yeah, it has to.
It has to, and
Like
the easiest place to go is
the cap. Or the
cork.
cork,
Right,
yeah.
cork. So, yeah, basically that's what happened.
What happens if like the weakest point was like the side of the bottle and it just exploded?
Yeah, that could happen. I've been using that for a long time, but I should probably make a new one pretty soon.
Yeah, you probably should.
That's why you guys stand behind me. So, that's basically what happened. You got your vapor, and then when I put the electricity through it and it arcs, what happens? It ignites. What's that mean? What happens to the speed of the particles inside that
they increase. They increase. That's why.
The
There's more
kinetic
collision.
energy increases,
Yeah,
right.
so there's more collisions, and
Right.
then, vapor pressure goes
The
up.
kinetic energy of the particles increases dramatically. And if the particles move faster, what do they do more often? Collide. If they collide, what builds?
Vapor pressure.
Vapor pressure. So that pressure builds, but this all happens like instantly. It builds very quickly, and the only weak spot for the vapor to get out is the cork. So it sends that cork flying, and remember, pressure goes from high pressure to low pressure. That's how pressure works. Gases or vapor, that's why the can was crushed, right? That's why the balloon got pushed inside the flask. That's why the cork pops off, because the vapor pressure inside is greater than outside. So it comes out, shoots the cork out. So I'm not going to have everybody read what they wrote, obviously. The writing part is just for you to practice getting it out of your head on paper. That's what you need to get good at by the end of the year. A lot of kids, a lot of people, I'm better explaining things than I am writing as well. But we got to practice writing our thoughts, okay? Because that's what you get graded on. So that was good. I like that demo. So we're still in our notes now. So we talked about vapor pressure with weak forces, meaning high vapor pressure. Strong forces, low vapor pressure. That concept's important. Next, we got to take out table H. Take that out. We're going to come back. We're going to get to it in a little bit, not right now. But take it out. Next thing we got to talk about. Let's see. Make sure I'm not forgetting anything. Oh. If a liquid is heated, the vapor pressure of that liquid does what? If we heat a liquid, does it produce more or less vapor? If you heat up water, does it evaporate faster or slower?
Faster.
Faster. Hope everybody understands that, okay? That's why in the wintertime, or maybe not in the winter, but even if it just rains, when the sun comes out, it dries up a lot faster because the sun heats up the water, it evaporates faster. So if a liquid is heated, the vapor pressure of that liquid increases. Why? Because it evaporates faster. There's more particles being evaporated, so therefore the vapor pressure increases. More collisions with the vapor. All right, the liquid is heated, but here's why. This is due to the particles gaining kinetic energy and evaporating faster. That's why that happens. I feel like you already know this, but we got to make sure we write it in the terms we have, chemistry terms, right? So particles gain kinetic energy, they evaporate faster. As a result, there's going to be more particles as vapor, like that picture A, and there's going to be more collisions, so more vapor pressure. And something else I want to talk about, I just remembered. So once you get this down, I'm going to talk about that first demo again real quick. Which has to do with this. Right? We heated it up by lighting it on fire. Which part of the acetone and the ethyl alcohol burned? The liquid or the vapor?
The vapor.
The vapor. Liquids actually don't burn. You could take a match, and if you were fast enough and the match didn't go out, you could take a container of alcohol, ethanol, the acetone, or gasoline. If you plunge that match into... Everyone else hear that? What is that?
It's a seagull.
What's that noise?
It's a seagull. I heard him this morning
It's a
too.
seagull?
Yeah, I swear to
How we
God.
get into school?
I was sitting in geometry and I heard a seagull.
You missed a
Swear.
couple demos, but we're kind of talking about them still.
No one else heard that.
I do have them online. Somebody recorded them anyway. But anyways, if you take a match and you plunge it into that container of gasoline without igniting the vapor, the liquid will put it out. The liquid will put it out. I mean, if you had something on a small flame, maybe a match, and you put it down and you dump a ton of gas on it very quickly, it might not light. The liquid will actually put it out. So why am I telling you this? I think it's important to understand liquids don't burn. So really, if this was the surface of the liquid, the flame would technically like hover like above it, kind of be like that. If we could zoom in, the liquid wouldn't be on fire; it would be hovering above it. That's what it would look like. The actual liquid does not burn; it's the vapor. So that's important to understand. Yeah.
You ever seen Man vs. Wild?
Yes.
He's in a cave. It's dark, so to save time, you put hand sanitizer, and it burns for like 20 minutes, and you just put a flame on it.
Yeah, hand sanitizer burns real well
For
because
like 20 minutes.
it's alcohol, but they got it in a kind of like a gel type state. So
And it doesn't go out.
right, because it's more dense. So that stuff back there is a liquid. That's more like a solid. Yeah, same concept. Burns the vapor.
Use that as a liquid.
All right. So back to this.
Camera guy, you got a hand sanitizer?
All right. Back to this. So if we decrease temperature, we cool down.